Welcome back, guys. This is the third video on triangles, and in this video I'm going to be showing you how to put these triangles in a hierarchy or in an order. And again, this is also a 5th grade math geometry unit. Now that we've gotten the very basic vocabulary of triangles, including their sides and their angles, and we also got some basics on how to name these triangles according to their sides and their angles, it is time that we put these triangles in order. So anytime when you see triangles are being grouped in this kind of a graphic organizer, it is being referred to as a hierarchy of triangles. The word hierarchy reminds me of like a family tree, where we can put our ancestors, our relatives in certain order in our family. Notice there are some empty spots. As a 5th grade mathematician, you will be asked to fill in these empty spots. My suggestions, if I were you, is to look at clues they gave us. And the next thing that you want to do is to draw pictures, because we're talking about shape. So this helps me to determine that they are classifying these triangles by their sides. And what do we know about classifying triangles by sides? If this one has 3 congruent sides, we know that there's also one without or 0 congruent sides, and the other one with at least 2 congruent sides. And if you guessed their names were scalene and isosceles, you were absolutely correct. But we know that it doesn't stop there. We can also further break these down into even more specific names using their angle. We know that from our table, from our chart, that it is impossible to make a right equilateral or an obtuse equilateral triangle. So we know that the only thing that is possible for equilateral is an acute triangle. So I'm going to go ahead and put it here. Notice there are 2 other arrows that are pointing to it, one from scalene right here, and one from isosceles. That tells me that isosceles and scalenes also have acute scalene or acute isosceles. They look like this. Now, 2 other types of angles that we've also discussed would be right angles. And as we know from the tables, there can be some right isosceles as well as right scalene, and they look like these. Go ahead and pause me so that you can teach yourself why those new triangles are right and why one is isosceles and the other is a scalene. The last one that we can look at with angles would be obtuse. We have obtuse isosceles and also obtuse scalene, and they look like this. Now go ahead and pause me so that you can identify why each of those were obtuse and why each of those were isosceles and scalene. As 5th graders, you will also see other type of hierarchy graphic organizers when we're talking about triangles. So at this time, I'm going to help you to understand what each of these graphic organizers mean and the relationship between the triangles that they're talking about. Let's look at this graphic organizer first. In its simplest form, when we're going from the bottom up, what we're trying to say is that an equilateral is always an isosceles because of this connection by this line. And it is also true that an equilateral is always a triangle because it is connected to this line as well. What is also true too that we can look at is this isosceles is always a triangle. Notice how when I'm going from the bottom up, what is at the bottom is always true to what's right above it. Okay, now, but when I'm going from the top down, the opposite is true. So for example, not every triangle is an isosceles, and not every isosceles is an equilateral. Does that make sense? I need you to pause right now to review this because it is very important when you're working with questions. If you don't understand this relationship right here, the wording can quickly confuse you. The same is true for this type of graphic organizer. So what this means is that when you know how to read one type of graphic organizer, you also know how to read all of the graphic organizers. So consider this. When you're going from bottom up, it's always true. So we can also apply it so we can use the same concept, but looking at it from the smallest group in comparison or in relation to the larger group. With that said, from smallest to largest is always true. For example, an equilateral is always an isosceles, and an equilateral, because it's inside this larger circle of triangles, it is also always a triangle. Same thing, isosceles is inside the bigger triangles circle, therefore isosceles is always a triangle. Same with scalene. Scalene is inside the triangles group, therefore scalene is always a triangle. But when we go from bigger to small, it is not always true. So for example, a triangle is not always an isosceles. Triangle is not always a scalene. Triangles is not always an equilateral. But an equilateral is always an isosceles. But notice, isosceles is not always an equilateral. I need you to pause the video to process all of that. I know it's a lot. It's not difficult. It's just taking the time to process what we just learned. But you need to teach yourself to see those relationships, especially with where they are positioned inside the graphic organizer and how the smaller group is compared to the larger group, and what is always true and what is not always true.